I know it's one presentation after the other. I will try to keep you on board, let's say. Please take something to drink before I start.
Do you want it or will I change your?
Look in this.
Yeah.
So I'm standing here alone with my name, but it shouldn't be like that. Basically what I present is a co-work, more or less the same group as shown by Marcel. Especially this house here, so the Water Research Institute of Slovakia is in all these projects. In a central position, Katarina is here. I don't know if Katarina Holubova is also here, but she was also in the past very much involved in this. The Hungarian colleagues, so basically from Germany to the Black Sea. So I have just the honor to present some work which we jointly did the last 10 years or more. Following what was said before by Marcel, now we look into one specific topic, not anymore about the fish, although this is influencing fish and so on. We want to focus on the sediment continuity, again continuity, and management measures. I will not go to all measures, I think, but I show you where are we at the moment. We are not done yet, but we are hopefully in a good way. So what are the sediment-related impacts? And you know most of them. I guess first of them here, we changed the river morphology a lot. Also here in Slovakia, as you know, of course. So we have the straightening, the less width. And if you want to summarize this regulation impact, it's quite astonishing that the upper Danube, which starts somewhere downstream of Bratislava. So Bratislava belongs to the upper Danube, and then we have this nick point in the longitudinal section I haven't brought with me, where then the middle Danube, basically in Hungary, starts, and then we have the lower Danube, basically here in Romania, Bulgaria border section of 1,000 kilometers in the delta. So if we look upstream of Bratislava, including Bratislava, we have a width reduction of almost 40%. So the Danube is smaller in width. In the cities, like in Vienna, it's even worse. In Vienna, it was 3 kilometers wide. Now we have 300 meters. So 3,000, now 300. That must have an impact. The length is shorter. We straightened the river. You see it especially in Germany, but also in Austria, minus 11%. So what is the consequence? It is steeper. Smaller and steeper is no good combination for sediment transport because it increases transport capacity, so the Danube is much more able to transport sediments, but not always. If we have a reservoir, like in the city of Bratislava, then we have the opposite, which gives us then sedimentation. But in general, in free-flowing river sections, which we have left over, only a few of them in the main stem, we get more transport. In the middle Danube, it's minus 12% width, minus 4% length, and it's less in the lower Danube. Here we have a minus 4% only, so the lower Danube is maybe more natural, you could say, than the rest of it, which makes it different, and only minus 1%. So it could be also summarized here already that there's much more need for restoration here and upstream compared to the downstream area, but also in Hungary there's a lot of things that are discussed nowadays. So we have this shorter, smaller in width. Then we have all these dots here, and I don't go into that because what Marcel showed was mainly the bigger hydropower plants. If you look to Austria, which is this red dotted area, we have only in Austria, a small country, we have 5,200 hydropower plants. So they are not included because they are small. Small means less than 10 megawatt power, but it's already not so small, I would say, in many places. We have less points here, also seen by Marcel, but there's a wave here, especially in the Balkan areas, to build a lot of new hydropower plants. And what we should not do is do the copy-paste, you know. All of us like copy-paste, you know, in a report or something. But maybe not here. Because we would also copy-paste the errors, the mistakes. And one of the big mistakes is we stop the sediment continuity. This is an issue. Also here in the Junava reservoir, or let's say in the Kapchikova reservoir, we have this issue. In that times before, sediment continuity was not an issue. So you could do something there, flushing, sluicing, as you will see. There's hope, I think, but it is difficult to change things once a reservoir is already existing. But it's not undoable. And if another point here, dredging, just some impacts here, a huge amount of sediments are taken out. Now we talk a lot about the twin cities, Vienna and Bratislava. I come from Vienna, I'm now here in Bratislava, and we have a lot of commonalities, a joint riverage, but also the question in the city of Vienna, Verbund, the hydropower company, is dumping every year 230,000 cubic meters of gravel. This is transported 3 kilometers per year. So it ends up where? Here in Slovakia. Maybe you can take out this gravel, but it's also a risk for flood risk maybe, or whatever it could be. So there's now a circular economy starting, taking the sediment, having a trap before it goes to Slovakia, putting it back upstream 19 kilometers, and it goes back and forth. I will show you some of these measures later. But as soon as you start with this, it's a lot of money involved in the management. What should not be the case is to take the sediments out of the river. Of course it is done, but it shouldn't be done on the commercial way because we have a deficit. Now if you compare the historic situation of sediment transport, and here only the fines, less than 1 millimeter, the fine stuff, clay, silt, fine sand. And you compare the situation before the hydropower plants with what we have now, you see here a big reduction. To make it shorter, you could say at the end of the Danube, in the Black Sea, we have a minus of 60%. So instead of having here 40 to 60 million tons, we have now only 15 to 20 million tons. And you see always this zigzag line. Now this is the Austrian, here's Junovo, Kapchik over here, we are now sitting. We have also a step here. So less sediments go out in comparison to the past as an input to the Hungarian section. And so we can go to the iron gate, a big trap, 80% of the sediments that go into the iron gate does not leave it. At the end in Belgrade, you would have to dredge or you build higher dams for flood risk. Now they increased the dam height by, I think, 1 meter. On the long run, it's not working out. If you make it as a sediment balance, and it's not complete, the Hungarian colleagues work a lot in this direction, what you see is the ancient Danube and the tributaries and the existing one. Now, in opposition to us as humans, where we say we shouldn't eat too much, from the weight. For the rivers, it's the opposite. This we call a hungry river. Why? What you see here is exactly the same thing. How much did the Danube transport before, and how little today? So it became slim. Some people would say slim fits or whatever, it should be healthy. But it's not for rivers. We transport them from a mighty river, let's take it indifferent, to a hungry river. As Matt Condolf in the USA wrote a nice paper on this. So anyway, but not only the Danube got smaller in size, but also the tributaries. Look at the Morava here, Morava before, Morava now, Sava, Drava, Raba, and you could name it. So at the end of the day, we managed quite nicely, but not nearly nice in a way, quite significantly, the Danube, from this to there. This must have a consequence. A lot of people might say it doesn't interest. And this is only suspended sediments. If we would go for the bed load, it would be even worse. We don't have enough data, unfortunately. This institute here takes a lot of efforts to measure, and very successfully measures now also since years, I would say, the suspended sediments and bed load, which is very much important. Without those data, we couldn't know what is going on. Like if you would be a medical doctor and you have no idea of any parameter, how could you treat the patient? What are the consequences now? Are we interested in this topic? And we have to see, here is the coastline in Romania. What you see here is coastal erosion. So, also here you see the tendencies. Romania is losing land. You could say, if you go to the delta, you should go once. It's really nice to see. But what they have here is a coastal erosion, like you see here, of up to 24 meters per year. No country will easily accept this. If you have tourism, it's not nice, because the sand beaches we like, they disappear. They disappear not only at the Danube, at the Rhine, at the Elbe, at the Po River. We go to Italy in summertime, you find a nice sand beach. It's artificially put there with machines, with, let's say, dredging from the sea, put it back to the sand beach, distribute it. If you go in Easter time to Grado, you know Grado, I guess, you could see it. This is a lot of money, a lot of money, and it's not ecologically sound in a way. So the rivers are not able to transport the sediments here. So at the end of the day, you see it here as well. This is erosion. So houses that stand here fall into the ocean. I was just here 1 year ago. There, I was 1 year ago. You could see fisher houses. They try to protect it with sandbags, but the ocean takes it. And the Ukraine colleagues in Kiev, unfortunately we have the war there, they gave us data for the underwater delta, and it showed the same dimensions. At the end, the delta might subside, sink down, which is not a good idea. Especially when you have sea level rise because of climate change. So we have to do something there. That's the end of the conveyor belt. But not only there, unfortunately. This is an Austrian databases. You see the years here. You could put the new years, that didn't change too much, a little bit it got better. With the free eye, without the trend line, you see the river goes down. So the river in Austria, upstream from here, is 1 meter lower, like the table's height, than it used to be 6 years ago. And we see it in the groundwater, in a national park, it's not good, drying up maybe. So we cannot wait for this and have not time to go into this. And if we don't stop this, we go into the fine material, which is then kind of marine sediments, where you might have a canyon type of erosion, and then the ships might not be able to go. So we cannot wait, and we must not wait to the very end. But this is also in Hungary, it's also in Romania. You see always the years here. That's what the river does. Or here, you see the lines here. That goes down, goes down, goes down, until the gravel is away for the upstream Danube. Either we go to rock in a Wachau area, which is also not good for fish, no spawning, also not for the ships. You would not want to collide a ship with not only an iceberg, but also the rocks are not good. So the army should blow up the rocks then, which is not the solution in the long run. So we cannot wait for this endless. And I don't go to all of these because it was mentioned. We have different morphological types. Also the colleague here from the Water Research Institute did that study quite nicely. And at the end of the day, we transformed the Danube completely to a different type. Maybe it's boring, it's single thread, it's not braiding, it's not, let's say, giving the meandering course anymore as it used to be. What is also important here, look just at this, please, at these colors. So red colors is erosion, the river goes down. Yellow one, brownish one, the river goes up. Green is what we are looking for. Green is equilibrium. We know a river is not fully equilibrium, but we don't want to see the erosion and the sedimentation. So if we summarize this, all these points, here is only crosses because the data quality was not enough, but still it's more red erosion. What we have here is 56% of 2,600 kilometers eroding, 34% sedimentation, and only 10%, 260 kilometers are in a shape we would say that's more or less okay. So what to do? We have to do something about it. That's what we think at least. So we started a new project, Danube Sediment Q2, also with sediment quality. We have Danube Fall and other projects like InnoSet that work in this direction to solve the problem now. To solve it, the first thing is we have to convince the countries. It's not us as scientists to say this is necessary. We cannot decide this. But the ICPDR, and this is nothing else than the community of 10 countries, decided this year, and I don't read it, but the good news is since 2 years more or less, it is clear after 30 years of discussion, fighting even, not agreeing, they came to a conclusion, yes, this is a problem. So sediment alteration is a problem on the same level like fish migration now, which is a good step forward. So there's a vision here. We know that the vision cannot be fulfilled. No one can completely restore the sediment balance. But to work in this direction is important. So we have this basis. It's a solid basis written down, agreed by all countries. But how? Next question is, how can we reach this? So we know it's not good, it's completely disturbed. We have an acceptance of the countries, including Slovakia and the other countries, but what to do? And this ends then, ended at the last project in the sediment management guidance and is now going to a sediment management plan. And again, you see here a lot of comments, but I show you more pictures, I think, to understand those measures. This is also downloadable in the Soil Sediment Management Guidance document, so you can search for it. I hope it's still possible to download it, otherwise you can write me an email and I can send you this. Basically, you have a lot of measures you can do. Measures in the catchment, measures in the reaches that Marcel mentioned, measures on the point scale at the dam and down to the delta. So there is hope in a way to do something. It's just the question who does it, when, and how is it working. How is it working? Not going into details, so we have measures. So we have measures in the free-flowing sections, no storage, measures in the reservoirs. So here in Bratislava, we would be in this part. Upstream, we would be in this part. So what can we do? We can change the sediment regime. The question is, if you have less gravel coming in, we have to do something. Either we allow the river to transport it, or we have to artificially dump sediment, gravel, into the river. That's what in Austria is done since many years now. 230,000 cubic meters of gravel. That's millions of euros per year to be dumped in. But alone it's not enough. We need to change the bed resistance eventually, or reduce the energy slope, or minimize the bed shear stress. But I better show you some examples how it could work. It's a combination of measures. But we think without a sediment continuity it does not work. We have a lot of discussions with engineering companies, but also with hydropower plants. They would say, before you don't restore the river downstream, we don't improve the sediment continuity. But without a sediment continuity, we cannot live at all. Why? Because we cannot change the Danube completely, because we still have navigation, we still need electricity. It's quite clear to us. So no one can be so unrealistic to say we blow up all the hydropower plants, we stop the navigation. That's not possible. So we have to work together in a sense, and because there's so much money involved, there should be some attempts to let the river do the job at the end. So we came up with many fact sheets and things like that, measures in the catchment, because here's also something. Why would the agriculture want to lose soil? No, they don't. They should keep the soil on the fields. Unfortunately, with new production lines, with climate change, more and more soil is eroded. It comes into the river with pesticides, PFAS. We don't want in the river. So we have to go to the catchment. But then we have to go to the reach scale, and we differentiate it here, impoundments and free-flowing sections, and measures at the dams. But I show you some pictures. It's more understandable than the text here. So this is found to be found here. And as I said, we have different ways to work at the catchment scale. I go again to some examples. So we have these fact sheets. They are further developed now in Danube sediment and also in Danube for all, extended to fish as well. So we would say, for example, in the upstream area in the mountains, we want some different structures than in the past. So sediments, and I speak here about mountainous areas in Austria, but also here in Slovakia you have mountainous areas. We don't want to have check dams that completely interrupt the sediment continuity, but we know that there's a settlement downstream, we need to do something. So let's build some open check dams where some size of sediments that can be transported further can go through. This is not easy, it can be blocked, and we all know the stories about this, but this is one way to build new types of dams here. If you go to the sectional scale, I show you some examples here as well. This is, for example, to the hydropower, but more on the reservoir side. What we have here is one thing that we have built, not here in Bratislava because it's a city, but in other places. We have built very wide reservoir at the Inn River. The problem starts already at the Inn River. Big reservoirs, and the idea was to build a lake, multifunctional lakes. They are now Ramsar sites even. That's also a contradiction in a way. And we have to discuss, not fight, but discuss intensely with ecologists, because they have now this wide area and they have a lot of birds there with shallow water. But now it's drying up because too much sediment is there. So we want to have a slim reservoir. Maybe we have to support the reservoir by groins and structures to make it slim. Why? If it's too wide, you have sedimentation. We want to get the sediment through. And in Innocent, in the other project, led by the Hungarian colleagues, we try to build something like this. Not only to open the gates, but also to have a reservoir where the sediments can go through. And that's what I mean with copy-paste errors, you know. Why would you do the same thing if you know it already doesn't work? For sediments at least. Next example, sediment bypass, also in the high up alpine areas, but also we try to think about those also for lowland river hydropower plants. It's sediment bypass tunnels. Now we don't have one in Austria, but the world champions are the Japanese and the Swiss. They have a workshop series now. It's a tunnel in the mountains where you can flush through, or let's say bypass, like for the heart, big stones even. The Japanese colleagues have the problem that their coast is eroded. Not a good idea. Tokyo, all the big cities are on the coastline. And if the coast is eroded, they lose not only the land with low, let's say, budgetary houses or whatever, but it's the cities itself. And they were successful. You could see progression, extension of the delta again. And also in Switzerland it worked out. We tried to get one in Austria, but how can we do it for lowland rivers like for here? Junova, that's not so simple. We are thinking of some of those solutions, but not yet they are on the table fully, with vortex tubes or whatever. It's much easier, I have to say, for fine material compared to the big stones. That's quite clear. Or we could have off-stream reservoirs so that the water is taken out, not to stop the continuity in the main river. The only problem here is when you do this, then we get here vegetation, and this is something we have at Junovo. You take the water out, it's a water abstraction, and the old Danube has less water, and then the vegetation is increasing. We all know this, more roughness, more sedimentation, and it's a circle you start with. Sluicing is another sluicing we favor a lot. This is something we would like to see also for Junovo in the Danube sediment program. So that, because no one needs the sediment in the city too much, no? Here. For this you need an installation, for example, you need a possibility with the bottom outlets. That's again the copy-paste thing. We need here to construct the weirs in a different way in future that the sediments can be sluiced through, or if not, flushed through. What is the difference between sluicing and flushing? Sluicing means the sedimentation is minimized. Flushing means you have already sedimentation, you flush it out. The problem with flushing is, we can do it, you get higher sediment concentrations then. Even unintentional, like in Austria, in the 2013 and 2002 floods, the biggest trap was flushed, Aschach, and in both floods, 4.5 million cubic meters of sediments were flushed out within a few days. This ends up in sedimentation, somewhere damages downstream. And I could show you pictures of 2 meters of sedimentation. It's too much then. So we want to get the sediments more gently through. Continuously, it's not possible, I guess, but a little bit less spiky, you know. So sluicing would be really a good idea, we think. Venting or turbidity currents, again here, in this case, in higher reservoir, alpine ones or other ones, you could manage to open the bottom outlet and let the density currents with sediments, if the water temperature is different, go through without sedimentation. This is not easy in all places, I know, but this is also one possibility. Flushing, environmentally flushing, again here the other thing is, we don't want to kill the fish. What is the critical concentration? We do some experiments in our lab nowadays. In Austria, it's 1 gram per liter. And if you ask the people, why 1 gram, why not 2, why not 3, why not 4 grams? Someone said this, you know. Again, copy-paste. So we found the literature, everyone took it. In Austria, it was in 1960 or 61, written in the USA. They had a big boat, steering with a pedal, and there were sediments in, because if you don't steer, the sediment goes down to the bottom. And then the fish in, and then they counted the fish that died. But no one knew what is with the oxygen at that time, what was with the temperature. If you have higher temperature, less oxygen, fish die because of sediments or not. So we do now flowing experience with flowing water and with fish. And I can tell you, we publish it soon, it's much more. Maybe it's 5 grams. On a permanent, let's say permanent experiment with fish, permanent means hours or days, they would not die. Maybe 5 is too much. But for 1 they can survive. You can flush, you can have 1 gram per liter all the time. They will not die. But on the other side, we want not to disturb them too much. So what is it? But if we have a certain better data, let's say, to say this is the amount, we could use this. Flat condition flushing would be, of course, an option. Also, we have to look into series of dams. We have 10 dams in Austria, so I don't want time-wise now to go all of them. I knew that this is too much, but just a few things. We could also dredge and reinsert. This is costly, but to take it out and dump it, it's even more costly, 40 euros per cubic meter in Austria. Where to dump the material? Can you dump it somewhere? Payload drift. You have in small hydropower the chance to get this, even the payload through. Some last examples. What is very important, a big mistake, what we did is this one. In the past, we always have double the width, always on the weir compared to the regulation. You see it here. This is a new version that was built now, and we get some success. Even the payload goes through. That means we have to reduce this width here. The turbine chambers should be in the bank, in the river bank, or even outside, so that the river itself doesn't get the overwidth. Or here, the bottom is also a topic. Like in the past, we built a high concrete here. You can lift all the gates here. This concrete cannot be moved. So the slope cannot be too high, or cannot be high enough to transport the sediments. So what we want is to lower this, or if a new planning is done, please don't make overwidth, please don't make the bottom of the concrete so high that the slope cannot be increased. And it's much easier today to build sluices that are the steelwork can be produced in a different way. Bypasses I mentioned, and so I can go through that. Not needed to go to all of them. So I wanted just to give some examples of barriers, that there are ideas also with turbine companies. Maybe new turbines can live with the small particles, so we can produce electricity and get the sediments through. And to finish off now, this is all done in the sediment Q2 project now. We want to have the first time a sediment management plan. Don't go into this. We work quite hard now, and the time is running. We have to finish it next year. The first time a sediment management plan for the Danube Basin, which links up to the continuity nicely. And then, of course, here I have not to say anything, I think, anymore, because Danube Fall was presented by Marcel nicely before. With that, I can thank you very much for the attention and open for questions. Thank you very much.